Good morning friends, welcome back to Parnika tutorials. In the last video, I have discussed how to implement the queue using the array. I hope you have watched that video. If you did not watch that video, I request you to go back and watch that video and come back to this video. In this video, I want to discuss how to implement the queue using the linked list. So I request everyone to watch the complete video for better understanding. First, let me discuss what is the limitation with the array. Then we will discuss about the linked list and the queue and how to implement the queue using the linked list. What is an array? Array is a collection of homogeneous elements. Now collection means we have to specify the number of elements also. The number of elements can be stored in an array depends on the size of the array. Usually we will declare an array with a data type, name of the array and the size. This data type specifies what kind of values you can store and the name of the array and how many elements you can store. Now the array index will start from 0 and go up to size -1. As in this example size is 5, the index is going up to 4. Now the arrays follows the concept called static memory allocation, means allocating the memory during the compile time we will call it as static memory allocation. So once you declared an array, the memory will be allocated. Now how much memory will be allocated based on what kind of compiler you are using. If you are using a 32-bit compiler, you know that one integer variable will occupy 4 bytes. So if one integer variable occupy 4 bytes, 5 such integer variables will occupy 5 into 4, 20 bytes. So 20 bytes of memory will be allocated. Okay, so you cannot increase or decrease the size of the array during the runtime. To overcome this limitation, the developers have introduced the concept called dynamic memory allocation. Using the functions such as malloc, calloc and realloc, we can allocate the memory during the runtime. Okay, so in the C programming lectures, I have discussed in detail about these functions with examples also. If you don't know this malloc and its syntax, I request you to watch the C programming lectures and come back to this video. In data structures course, I have discussed about the single linked list. I hope you have watched that video. Even if you don't know the single linked list, what is its representation, how to insert a node at the beginning or at the end or at any position or deletion, all these things if you don't know, I request you to watch that video. If you know what is a queue and what is the dynamic memory allocation and the single linked list, then only I request you to watch this video. Then only you will understand the concept in a better way. Now let me give an overview about the single linked list. The single linked list, the memory will be allocated dynamically. So it will do the runtime memory allocation. Now a single linked list will have a collection of nodes. A node will have the data and address of the next node. When it comes to the array, all the elements will be stored in contiguous memory locations. Meaning is that if this base address is 100 and you know that one integer variable will occupy 4 bytes. So from 100th byte to 103 bytes, the first element will be stored. From 104 to 107, the second element will be stored. From 108 to 11 byte, the third element will be stored. 112 to 115, 116 to 119. However, we will always specify the starting byte 100, 104, 108, 112, 116. So they are contiguous locations. Okay. But however, as the memory is allocated during the runtime, they may not be contiguous memory allocation. So the address of the next node should be there in this current node. Okay. So using this address, you will go to the particular location and you will access this element. Now, as I said, we will have the data. Let's take that I have the data 20, 10, 20, 30. And we will have a head pointer which is pointing to the first node in the single linked list. And the last node, look at this node. This is the last node. After this node, there is no other node to point. So at the last node, the address of the next node should be null. Okay, is it clear? So this is about the overview of the single linked list. Now let me discuss about the queue. Queue is a linear data structure where the operations such as enqueue and dequeue will be performed in a particular way. Now let me give an overview about the queue. Okay, we will have two pointers or the two variables called front and rear. Okay, the enqueue operation meaning is that insertion in the queue will be happen from the rear, and the dequeue or the deleting an element from the node should be performed from the front, because the queue follows the first in first out principle or last in last out principle. The node which you have inserted first, you have to delete it first, okay, or the element which you have inserted last, you have to delete it last. Okay, now this is about an overview about the front, means the queue. Initially when the queue is empty, front and rear will be equal to -1 if you are using the arrays. Okay, now coming to the linked list, if you want to implement the queue using the linked list, you know that insertion should be done at the end, because that is what you said. If I take this as the front, first and rear, then insertion should be happen from the rear. So if you want to insert a new element, you have to insert here. Am I right? Suppose its address is 400, then you will have the address here as 400, and let's take that you have the element 40 here, and the address of the next node will be null. So any node, if you want to insert into the queue, you should do at the end. If you want to delete any element, or if you want to perform the dequeue operation, you have to do at the starting. Now if you want to delete an element from the beginning in a single linked list, you know that it will take order of 1. Am I right? But when you use a only single pointer called head, which is pointing to the first node, if you want to insert any element from the at the end, okay, then you have to traverse all these nodes, then only you will come here. Then here let's take that you have created a new node. Okay, this new node will have the address of this node. Okay, let's take that value is 50 and you have the null. Now you need to come up to here and using some pointer called temp or some pointer, then you have to write temp of next. Let's take that using a pointer called temp, you have came up to here. Then what you have to write, you have to keep the here the address of this node. The address of this node is 500. Okay, then what you have to write, temp of next is equal to new node you should write. Then it will have the 500 here. Then only the access will, means the node can be inserted. So if you want to traverse all these nodes, the time will be taken, how many nodes are there, but we can say generalized it is order of n. So if you want to insert an element at the end using a single pointer in a linked list, it will take order of n time. But when it comes to the queue, the enqueue operation and dequeue operation should happen in the order of 1 only. It should not happen of order of n. Okay, is it clear? So that's why what we have to do is that using single pointer it is not possible. So we will maintain 2 pointers. One is the front, okay, which is pointing to the first element in the linked list, and we will have the rear. Let me maintain here rear because this is the last node. Rear will be there at the last node. So front will be there pointing to the first node and rear will be pointing to the last node in this linked list. If you want to insert any node, so you will say rear of next is equal to new node. So with an order of 1 you are doing the insertion and also deletion. So this is about an overview. Now let me discuss the how to perform the enqueue operation and dequeue operation in a queue using the single linked list. Okay, to do that one, I have to create a node, okay, or I have to define a node using what? Using the structures. Okay, so let me define a structure called node, okay, which consists of 2 things. One is the data and another one is the address of the next node. Let me write it as next. Okay, so this is a structure definition. You will have strut keyword, name of the structure and the members. You close the curly braces and ends with a semicolon. Now I want to define 2 pointers. of strut node types. So strut node front, and then strut node rear. At the starting itself, let me declare them as null. So they are null pointers. Okay, is it clear? They are not pointing to any memory location. Now initially front and rear is equal to null, meaning is that there are no elements inside the queue. Is it clear? Now in that case, what you want to do, you want to insert a node. So you have to write a function for enqueue. Oh, sorry. This is the user defined function called enqueue, and the return type is void. So this function does not return anything, and this function does not take any parameters. So what I have to do is that first I need to declare a pointer of strut node. Let me take it as new node. Okay. And I will ask the user to enter the data. So let me take another variable called int x. Okay. Printf, enter the value. Once the user has entered the value, I will scan that value using the scanf function, and I will write the address of that variable x. Then what I will do, new node of data is equal to x, then new node of next I will make it as null. So what is happening is that you are creating a new node, okay, of suppose let's take that in address 100. So new node will have the new node pointer will have the addresses 100, which is pointing to this memory which is allocated using the dynamic memory allocation. Have we done the dynamic memory allocation? We have declared the variable. Okay, have we allocated the memory? We have forgot to allocate the memory. Let me write here. Okay, let me write here. So let me use the red pen. I forgot to allocate the memory. So what should I write? New node is equal to, okay, strut node star, meaning is that the malloc function will return a void pointer. So you have to do the typecasting malloc. You have to specify the size. So size of strut node. Sorry to mistake for it. I forgot to write this statement. Once you declared a variable called new node of strut, you have to create the new node using the function called malloc, or you can use a function called calloc also. So this is the syntax for allocating the memory dynamically using the malloc function. Then I have asked the user to enter the value, and I read it, and then new node of data is equal to x, new node of next is equal to null. So here the value, suppose let's take that x has entered the value as 10, so the 10 value will be here, and here you are making it as a null. So this node you want to insert. Okay, how you can insert it? You can insert like, if the queue is empty, then what you have to do, if front is equal to null, then you can say that queue is empty. If queue is empty, then this is the first node which you are inserting. So let's assume that front is equal to null before inserting this one, and rear is equal to null. So this is the first node. If front is equal to null, right now the queue is empty. If queue is empty, this is the first node you are inserting. Then the front and rear will be pointing to this node only. So you have to write front is equal to new node, rear is equal to new node. Okay, so what is this new node consists of? 100 of address of this node. So both this node pointers, front and rear, is pointing to this node. So when front and rear is having the same address, you can say that only one element is there in the queue. Is it clear? Are you able to understand? If it is wrong, if front is not equal to null, then you can say that some elements are there in the linked list. Suppose let's take that one element is there. Again you are creating a new node. Okay, then what you have to do, suppose let's assume, let me write here, already one node is there in the linked list with the value 10, and here null is there, and you have the front is consists of 100. Let's assume that this address of this node is 100, and you have another node. So now both this front and rear is pointing to the first node. Now you have called the enqueue function, and again you created another node called new node, means you have created a node, and you have declared another variable called new node consists of the address of this node. Let's take that address of this node is 200, and you have insert the 20 value here, and you have the null. Now where you have to insert this node, you have to insert here, because always the enqueue operation should be done at the end. Dequeue operation should be done from the beginning in the linked list. So what you have to write here, okay, you have to write rear of next, which is nothing but 100 of next. Here you should bring the address of this node. So you can write else, okay, rear of next is equal to new node. Are you able to understand it or not? What is the new node is consists of? Is consists of address 200. So rear of next here 200 will come. Is it clear? So you have a pointer pointing to this node. Then what you have to do, the rear should point here. So what you have to write, then you have to write rear is equal to new node. So what is that value? 200. So now rear is having the address 200, which is pointing to this node. Now front is pointing to the first node, and rear is pointing to the next node. So again, if you call the enqueue function, then else block will be happen, and the nodes will be inserted at the end. Okay, so this is else block, and this is the close of the enqueue function. So this is the way you have to insert an element into the queue in a single linked list. Now let me discuss about the dequeue operation. Dequeue operation is nothing but deleting an element from the queue. Okay, now front is equal to 100 and rear is equal to 200. So there are some elements are there. Okay, let me write the dequeue function. Okay, if you want to delete any element, first you need to check whether the queue is empty or not. How you can check whether the queue is empty or not? If you write if front is equal to null, then queue is empty. If queue is empty, can you delete any elements? No, you cannot delete any elements. Queue is empty. If front is not equal to null, so let's take that front is equal to 100. 100 is not equal to null. The meaning is that some elements are there in the queue. Else, okay, else what you have to do is that you have to delete this element, which is the first node. Okay, how to delete is that we will create a variable called temp, which is struct node type. Okay, then I will write temp is equal to front. Then what will happen is that you are creating a variable called temp, which is having the 100 address. So even this temp is pointing to this first node. Then what you will write, you have to delete this node. How you can delete this node? Here first what you have to do is that first front should be pointing to the next node. So how it will point is that you will write front is equal to temp of next. Now what is temp of next? Temp is 100. 100 of next is 200. So now front will become 200. So which is pointing to the second node or this node. Okay. Now what you have to do? You have to delete this link. How can you delete this link? You can write temp of next is equal to null. Then here null will come because temp is 100. 100 of next is here. You are writing null. So this link is breaking. okay, or this link is broken. Now you have to delete this memory, or you have to free this memory which is allocated during the runtime. Using the function called free, you can delete the memory. So you have to use the pointer which is pointing to that memory. So you have to write free of temp. So temp is having 100, so that address which is there in the 100, okay, that memory will be deallocated. Okay, so this is done. Now look at what is temp is consists of. Temp is consists of 100. Whether the 100 address is there? No, not there. So a pointer which is pointing to an address which is not existing, that kind of pointer we will call it as a dangling pointer. This is very dangerous. So you have to make it as a null. That is a good practice, but lot of people will not do it. If you assign temp is equal to null, then it becomes a null pointer. Null pointer is not pointing to any address. Okay, so you should write temp is equal to null. Okay, so now let me close the else block. Let me close the dequeue function. So this is about the dequeue. Okay, so I hope you have understood how I perform the dequeue operation. Now let me discuss about the display function. Okay, by that time let's assume that we have inserted some more elements also. Let's assume that here it is 100 is there, 100, 200 and 300. You have the value 10, 20, 30. So here 200 is there, here 300 is there, and here null is there. Okay, and this here it is rare. So rare will have the 300. Front is pointing to the first node. Am I right? This is the queue which is having the 3 nodes, consists of values 10, 20 and 30. Now I want to display these elements. So void display, I will write a function. Before displaying, I need to check whether the queue is empty or not. How I can check? If front is equal to null, then I can say that queue is empty. If queue is empty, how can I display the elements? I cannot display the elements. Okay, else meaning is that there are some elements in the queue. If there are some elements are there in the queue, you need to display. How to display? Always you should display the elements as 10, 20, 30, because 10 was inserted first, then 20, then 30. So the element which was inserted first, that should be displayed. So 10, 20, 30 should be displayed. So you should display from here, here, here and up to here you should go. So then you have to declare one variable called temp, and you have to assign the value which is there in the front. So you are creating a variable called temp and you are writing the 100. Okay, is it clear? Then what we will do is that while temp not equal to null, okay, printf %d, okay, %d \t, okay, then you have to write what you have to write, temp of data. Is it clear? Close the else block, close the display function. Now let me discuss with a simple example. You have 3 elements. So temp is pointing to the first element. So temp of data. Now look at here. While temp not equal to null. Yes, 100 is not equal to null. This condition is true. If this condition is true, you need to display the element which is there in this node. What is the element which is there in this node? 10. How you can access that one? Temp of data. We have created a structure called int data and we have a one pointer which is pointing to the address of the next node. So temp of data, I will get the value 10. Then what I need to do? I forgot to write one point here. Is it clear? Then I have to write temp is equal to temp of next. Okay, then I need to close the while block, I need to close the else block, then I need to close the function. Once I printed this value, then temp should point to here. So how can it point? Temp is equal to temp of next. What is temp of next? 200. That you are storing it into the variable called temp. Now temp is pointing to the second node. Okay, now you check again. While temp not equal to null, yes, temp is having the value 200 which is not equal to null. Again the condition is true. So print of percentage d temp of data, which is 20, will be displayed. Then temp is equal to temp of next. So temp of next is 300. The 300 will come here. Then again the condition will be true. 300 not equal to null. Yes, again this condition is true. So you are writing temp of data. 300 of data is 30. Okay, are you able to understand it or not? Then you are writing temp is equal to temp of next. What is temp of next? Null. Here null is coming. Now again, once this statement is done, you will come to the condition. Temp not equal to null. No, null is equal to null. So this condition is false. If this condition is false, it will come out from the while loop. After that, we are closing the else block and we are closing this function. So this is the function to display the elements which are there in the queue. Okay, now let me discuss the function called peek to display the topmost element or the front element in the queue. If it is a stack, we will say that topmost element, whereas if it is a queue, we will say that first element in the queue. So I will write void peek. Okay, if queue is empty, then will you have a topmost element? No. Or the front element? No. So you have to write if front is equal to null, printf percentage d. Okay, so sorry, percentage d, why I will say queue is empty, I will write. Sorry for these mistakes. I hope you can understand. Okay, if front is equal to null, queue is empty. Else, you have to display the topmost element or the front element, percentage d, front of data. Okay, close the peek function. That's all. Is it clear? Front of data, front is 100, 100 of data is 10. That value will be displayed. So I hope you have understood how I have written the functions such as enqueue, dequeue, display and peek. In the last video, I have discussed about the main function. Okay, you declare this node structure globally and then you write this one globally. After that, you write the main function. Before that, you include the stdio.h and stdlib.h. In the main function, using the while loop and using the switch case, you ask the user what he has to do, whether he want to perform the insertion, deletion or display. Based on that one, you write. If he is writing the invalid choice, then you print the invalid choice. If he want to exit, give one choice for him. So this is the already in the last video I have discussed the main function. You use that main function and use these functions. Once you combine all these things, you can write one program and compile it. You will get the output. I hope you have understood all the concepts which I have discussed in this video. If you still have any doubts regarding these concepts, I request you to ask the doubts in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.